Hello guys, hello folks. I hope you are doing great. So here we are for our last case of non-exact differential equation. So okay, as we know, a non-exact differential equation, it is an equation in which the differential, suppose we have this expression like here. Okay, we have this mxy dx plus nxy dy equal to 0. So what should be our non-exact equation? Non-exact equation, okay, it should be something like if I have del of m, okay, if derivative of m with respect to y is different, okay, of derivative of n with respect to x. So then in this case we call non-exact differential equation. So the first thing we have to do is just to check, okay, for this fifth case, case number 5, we will analyze, okay, which method, okay, do we have, or which integrating factor do we have to find in case the function, okay, in case the not the function but the differential equation, the non-exact differential equation is given in this form here that you can see. Okay, now let us see. So if the differential equation is given in this form, what we have to see, or what we have to do, okay, to reduce this differential equation to a exact differential equation. So we know, okay, that to reduce any non-exact differential equation to a exact differential equation, we have to multiply the differential equation by the integrating factor. After multiplying by integrating factor, so we can just reduce this one into a reducible differential equation. And for this case, it will not be different. Okay, see, the condition to apply this case number 5 is only one. Okay, suppose the equation is not exact and it is in the form of x raised to m1 y, okay, x raised to m1 times y raised to n1 times a1 y dx plus b1 x dy. Okay, so here, if the equation is given in this form, what we have to do, we have to only do some basic calculation. So here it is given that the integration factor or integrating factor will be x raised to h times y raised to k. Okay, this will be the integrating factor. So here our problem is just to find what is h and what is k. Okay, but easily you can find h and k for this integrating factor by applying some very easy changes. Okay, so here you have just to do what is x, what is the power of x, m1, and here what is dx, dx is here, what is the constant of multiplying dx, a1. Okay, so here you will just set an equation like this: m1 plus h plus 1 divided by a1 must be equal to n1 plus k plus 1 divided by b1, that is with that is a product of dy. Okay, the same equation you will do with the second expression. Okay, m2 plus h and plus 1 divided by a2, and it will be equal to n2 plus k plus 1 divided by b2, as you can see here. Okay, and here, from here you will get what is your h and what is your k. After finding your h and k, this will be a system of linear equation you have just to solve, applying any method you know, any method you feel like easy, so it will be easily found. So after finding the value of h and k, you have just to substitute here and pick up this integrating factor, multiply by the whole expression, by the entire expression. Okay, in this way you will reduce this to an exact differential equation, and after reducing to this exact differential equation, you have just to apply the method of exact, okay, exact differential equation. That is this one, okay. Just put together all the terms with having dx, and put together all the terms having dy, then integrate both sides. After integrating both sides, you have to remember that the integration of m1 dx, okay, it must contain y constant, and the integration of n dy must exclude all the terms of x, okay. Then let us solve for this equation like this one. We solve for the first one and the second one. Stay with us. Okay, so here we have this exercise, okay. Okay, here we have two exercises. Okay, we are going to start by this one. Okay, we are going to start by this one. As you can see, this is x raised to 7, okay, x raised to 7, y square and 3y dx, and dx plus 3x raised to 8 y minus x dy equal to 0. So here, this equation, as you can see, it is not, how can I say, directly you can check that. Okay, here I know that this is m and this is n, okay. Just by comparing, you have just to compare, okay, this one as it is, n of xy and dy equal to 0. If you compare them, you will see that this is m and this is n. Yes, directly you will see this if you just compare. Now this is 8, okay, yeah. Now after comparing, you'll see that this is m and this is n. The next step is just to find the derivative of this guy, just to check whether this is this function is, this equation is exact or not. Okay, this is del n equal to this. So find what is, this is m, so derivative of this with respect to y. If you derive this one with respect to y, you will get 2y x raised to 7, then plus 3, okay. And if you derive this one with respect to x, you are going to have 8 down, so it will be 24 8 raised to 7 y minus 1. So clearly you can see that this del m del y are different than del n del x. So it means that this is not, it is not exact, okay. It is not exact differential equation. So it is not exact differential equation. What does it mean? It means that we need IF, okay. We need an integrating factor so that we can reduce this non-exact differential equation to an exact differential equation. But in this case, what should be our IF? That's the point, okay. See, is this function here, is this function homogeneous? No, it's not homogeneous, because the degree here is 9. The degree here of this polynomial is 9, of this monomial is 1, and of this polynomial is 9 also, but this is 1. So it cannot be homogeneous. So we cannot apply integrating factor for homogeneous function. So is this organized in the form of x, y in all the terms? Not and not. Is this, can we solve applying just how can I say, can we solve by the third or the fourth method? Okay, this is the way you have to check any integration, okay. But here, as we are solving for the fifth case, so we will just use the fifth case directly, okay. Yeah, but if you are not solving for a certain case, you can just go trying and error, try error, just to check at which condition you will just have this integration set in the differentiation set solved, okay. Okay, now what should be our IF? So here, this integration is not in the form of this one. It's not in this form, okay. It's not in this form. But the point is, can you reduce into this form? This is what we are going to check, okay. Here you have this one. The integration is x raised to 7 y squared plus 3y, okay, dx plus 3x raised to 8 plus minus x, this one. And here it is dy equal to 0. Can we reduce in this form? X raised to m1, y raised to n1, then a1 raised to y dx plus b1 x dy. Can we reduce? That's the point. That's what we are going to do. We are going to reduce in this form so that we can find if in the form of the fifth case. Okay, plus x m2 y n n2, and here I got a2 and y dx plus b2 x dy equal to 0. Can we reduce in this form? This is what we are going to do. Check. Now here we just multiply this and this and this and this. Okay, what we are going to have, then we are going to put together this term dx with this term dx, and this term dx with this term dx, just like this. So it will be x raised to 7 y square plus, okay, plus this and this will come also here, okay, like 3x raised to 8 y, okay, this will be dy, and this is dx, okay. Let me put here, okay, now sorry, let me write down here, okay, x raised to 7 y square dx plus 3x raised to 8 y dy, okay, then plus 3y dx minus x dy equal to 0. That's the point. Okay, yeah, okay, I just separate in this way. It's okay, it's nice. So the point here is just trying to do, okay, whatever you can. Okay, now here if you see, okay, if you see, you can take out here x raised to 7, x raised to 7, like the common factor here. You can take out x raised to 7, and here you can take out also y only, y. So this will be only here, what will remain? Will remain y dx. Okay, and here if I take this x raised to 7 and y, it will remain only 3x dy plus, here as you can see, this will be the same, 3y dx minus, okay, 3y dx minus x dy equal to 0. Okay, yeah, that just in this way. Okay, so now I can see that this expression here is in this form and this one is in this form. Okay, now if you can write in this form, so the next step is just to find now our if here. After comparing, our if will be x raised to h, then y raised to k, just like this. Okay, so what is our what is the how can I say, the equation that we, the relation between h, k, and so on? We said that this one will be equal to what? Will be m1 plus h plus 1, okay, all upon a1 is equal to n1 plus k plus 1 all upon b1, and m2 plus h plus 1 by a2 is equal to n2 plus k plus 1 upon b2. Okay, now the point is, what is b2, what is b2, b1, what is this m1? Okay, just compare, okay, this x and this x. It means that if you compare this and this, this and this, this and this, compare all the terms, what you're going to have, here x raised to 7 and here m. Okay, so it means that m1, okay, m1 is equal to 7. Okay, now n1 will be equal to 1, just like this. N1 will be equal to 1. And what about y? What about a1? A1 will be this here. What is the coefficient that is here? This is 1. So a1 is equal to 1. Okay, now go for the next how can I say, the next step. Okay, now what is our b1? Okay, b1, it is this one. Okay, so here it is b1. Just comparing, you will find, okay, this is 3 b1. Okay, this one, a1 is 1, m1 is 7. Okay, n1 is 1, b1 is 3. Now go for this one. Here we cannot see x raised to m1 and this one. Okay, we cannot see, but this is here. You can just say this is x raised to 0 and y raised to 0. Okay, this is true. X raised to 0 and y raised to 0. If I multiply this, will be 1, 1, 1, and it's okay. Fine. Now what you have to do, see, x raised to 0, it means that compare this and this. m2 is 0. n2 will be also 0. Okay, then just substitute what will be a2 and b2. Okay, so here m2 is 0, n2 is 0. Okay, b2, what is b2? This term here with dy, this minus 1. Okay, b2 is the coefficient, and the coefficient of dx, what is this? a2 is 3. Okay, just having this value, you know how to find now what is directly, okay, what is directly our h and our k. And now what you have to do is just substitute in this formula. If you substitute this, what you are going to have? Substitute in this. m1 plus h plus 1 upon a1. m1 is 7. This will be 7 plus h plus 1 all upon a1. What is a1? 1. Okay, equal to n1. What is n1? 1 plus k plus 1 all divided by b2. b2 is 3. And then solve for this also. m2 is 0. 0 plus h plus 1 all upon a2. a2 is 3. And here you get 0 plus, because it is n2 also, 0 plus k plus 1 divided by b2. b2 is minus 1. Okay, just solve for this equation, solve for this little equation, as you can see, and you will have this. After finding h and k, you just substitute in here. Okay, we are finding h and k to find out what is the integrating factor. After finding the integrating factor, we have just to multiply the integrating factor by the whole terms here, so it will be exact differential equation. Then we can solve by exact differential equation method. Okay, nice. So now we have this expression. Okay, what we have to do is just to solve this one. Okay, we can solve by this one. This will be just find this common denominator. We are going to have 21, like 21 plus 3, it will be 24. Okay, 24 plus 3h, okay, 3h equal to k plus 2. And here you are going to have h plus 1. Here just go there. This one will multiply by minus 1. Minus 1 come here. Minus 1 and 3 go there. Here you got 3k plus 3. Is that okay? Now what should be our k? So now what is missing here? You just to do some basic simplification. Okay, do just some basic simplification. 24 plus th is equal to k plus 2, and here you are going to have minus h minus 1 equal to 3k plus 3. Okay, So what you're going to do here, so this is 3h, right? So multiply here by 3h, okay? 3h multiply here. You are going to see it will be 24 plus 3h equal to k plus 2. So it will be minus 3h, and here it will be minus 3 equal to 9k plus, okay, 9k, right, 9k plus 9, okay. Yeah, if you just multiply by minus 3 all of this term, it will be this. Now sum all the expression here. Here this and this will be 0, this and this will be 21, and here what you're going to have, just sum this one, this will be 10k, okay. This and this will be 11, okay. This 11 go there, we are going to rest with 10, and here 10k means that k will be equal to 1. So if k is equal to 1, go just substitute the value of k in any of this equation and find what is h, okay. In any of this equation, find what is h, substituting the value of k. K is 1. What does it mean? It means that h, okay, h will be equal to minus 3, okay, minus 3 again, because k is 1, k here it makes no sense, will be 1 also, minus 3, so this will be minus 3, okay, multiplying by minus 1 here, yeah, minus 3, right, okay, it's minus 3, like then minus 1, okay, minus 1, so it will be minus 6, minus 1, this will be minus 7. This will be the value of h. So here we know that k is 1, okay, k must be 1, and h must be minus 7. Okay, if h is minus 7 and k is 1, now substitute. What is your if? If is h raised to x raised to h and y raised to k. So if will be equal to h raised to minus 7 and y raised to 1. This is your if. So this is the expression that we are going to pick up and multiply by the whole expression, okay. So what is the main expression here, or the main equation? The main equation, I don't know if you remember, it is this one, this equation. So we will multiply this equation by if, okay, simply like this. So it is x raised to minus 7 y, this is our if. I will multiply by x raised to 7, then y square plus 3y dx, then plus x raised to minus 7 y, okay, multiply by 3 x raised to 8 y minus x, and here dy equal to 0. Okay, as you can see, after multiplying this, you will get an expression like this. Do just some simplification, this and this, you are going to have this one, you're going to have only y cubed, and this you're going to have plus 3 upon x raised to 7 dx, plus, now do the same here, do the simplification, you are going to have 3x, okay, sorry, here this and this, it will be y square, okay, 3y square, okay, sorry, yeah, 3y square here, okay, because it's multiplication y and y, so 3y square. Then x and x, okay, this will be this, and this will be y square. Then multiply again this and this, it will be minus, okay, minus y upon x raised to 6 dx, y equal to 0. If you see here, this and this raised to 6, okay, and it's okay, just do this one. After solving this, what's the next step? Now find what is, now that you can see this is m1 and this is n1. If you find what is the derivative of this guy with respect to y, and find what is the derivative of this one with respect to x, you'll see that this must be the same. Okay, they must be the same. This must be the same. Okay, just find out this one. If I derive with respect to y here, this will be 3y squared. Okay, 3y squared. Okay, it will be 3y squared. Okay, then plus, I'm deriving with respect to this guy, this will be 6y, okay, raised to x power 7. Till here, it's okay, it's fine. Now here, what you're going to see, derive with respect to x, this will be 3y squared. Derive with respect to x, this will be minus, and here you are going to have y out, y will be a constant. Here you will get x raised to 5 negative and x raised to 12, just like this. So if you do some simplification here, you will end as this one positive, and here you will end with this is this is 5 and this is 6. Okay, yeah, because you are going to derive this expression derived like x raised to 6 derived up, then 1. And what you're going to see, this is you will end with an expression like this. Okay, minus 6y upon 5. Okay, 12 minus 5, this is x raised to 7, just like this. As you can see, okay, now del m1, okay, upon del y is equal to del n1 upon del x. See, they are equal. This term is equal to this. Okay, so if it is equal, so you can just solve. You can just come here and you see for this point here, at this point they are equal, they are exact. Now that they are exact, you can apply just integration here and integration here. Okay, just apply integration in both sides. So it will be y cubed plus, okay, plus y cubed plus 3y squared upon x raised to 7 dx plus 3x y squared minus y x raised to 6 dy equal to 0. Now that they are exact, you can just come here, apply integration, and this will become c. Okay, integration, c. Now see, y here will be a constant, and here x, okay, excluded. You will have to exclude all the term, okay, x exclude. You will just exclude all the terms of x, okay. Where you see x, exclude this from this dy, okay, the integration. So here this will be 0, exclude this will be 0. So, and here you will consider y as constant. So consider this y as constant. Just go here. What you are going to see, you are going to see this one, integration y cubed, y is a constant, dx plus 3y squared is a constant. So here you get x raised to minus 7 dx. So here y is constant, y constant. Okay, plus this integration is 0 dy equal to c. Okay, 0 dy, because all the terms here has x, so 0, 0, so it will be 0. Integration of 0 is 0. Okay, it's like you are trying to integrate nothing. Okay, yeah, it's nothing, no area, no way. Yeah, and you find just this integration here. This will be y cubed x plus 3y squared, and find this integration. This will be x raised to minus 7 plus 1 all upon minus 7 plus 1, okay, equal to c. Then just find this out. This will be xy cubed plus 3, and after finding this out, you're going to see this will be minus, and if you just find this common guy, this will be minus 6 and 3. Okay, so you can just put here 6, and here it will be 1 upon x raised to 6 equal to c. Just simplify this one, xy cubed, and here you get minus 1 upon 2, okay, time 1 upon x raised to 6 equal to c. So this will be your solution for your integral, the solution for your differential equation. This is by our fifth case. So the most important thing here in our fifth case is just to know, okay, you have just to be aware whether the function can be reducible in this form, okay, whether the function can be reducible in this form, okay, yeah, because sometimes they do not give you the function in the exact form, as you can see here. Let me see. Yes, suppose in this equation here, the function is already given in this form, up form. They give you x, and here y will be, okay, y raised to 0. So then you can just find what is m1, what is n1, what is a1, what is b1, what is a. Here you will just have x equal to 0. So m2 is 0, n2 will be 3, a2 will be 3, and b2 will be 5. So then you can just solve this exercise and go and okay. So this is the most important thing about these equations, okay. Sometimes they will give you in this form. Whenever you see an equation like this, you see inside there is the derivative of x and derivative of y, and x is like x is a product of with derivative of y, and y is a product with derivative of x, okay, and it is repeating here again. So you can apply this this case 5, okay, you can apply this case 5, okay, knowing that if you just displace all of this, you will get a non-exact differential equation, okay. So you can solve for this one and other more exercise. So just for finishing this chapter, okay, this non how can I say this, the name of this non-exact differential equation, I have here some exercise. Let me check, where is this? Okay, I have here some exercise, so you can pause the video and just start solving for them, okay. You can pause the video and just solve for them all of this exercise, okay. And it is not about only here you can apply multiple methods, but it's all about non-exact differential equation. You can apply any method of in between any case, okay, any of these 5 cases that we solved here, and so on and on. Suppose here you have this expression here, okay. For this expression, it is not homogeneous. If you derive this and derive this one, you will get a differential equation that are not, how can I say, you get this differentiation with respect to y will be only 2y, and this differentiation of n with respect to x will be y, so it will be not exact. So if it is not exact, which method do I have to use, or which case do I have to use? Now see, is this homogeneous function? No, it's not homogeneous function. Is this in form of x and y function? No, it's not in form of x, y function. Then you can apply, okay, then you can apply, what about this 5 case? The case number 5, how to solve this one with the case number 5? It is impossible to solve with the case number 5. Why? Because this is very simple. If you look at here, you will have only terms of x, okay, term of x here, and one term of y. For case number 5, you have to have 2 terms of x, okay, like dy dx and dx dy, you have to put it in group, and dy dx in another group. So it is not possible for this case. Here we have only one term for dy and many terms for dx. So for this case, the suitable way to solve this one is by case number 3, okay, or applying case number 4, okay. And for case number 3 should be more suitable. Yeah, case number 3 should be more suitable, because this should be like for this case you should just go for, because you know that del m del y will be equal to 2y, and del n del x here for this case will be equal to y. Now you can do the difference between them, then divide by n. So you have 2y minus y divided by n. What is your n? xy. You see? And here you are going to have what? You are going to have y upon xy. Y will be out, so this will be 1 upon x. And 1 upon x is a function of x only. So if it's a function of x only, then you can solve by this method directly. Okay, this is the way you have to check and to solve these equations. You have to be analytic. Okay, this one also can be solved by case number 3 or number 4. And let me see, this one also can be solved by case number 3 or number 4. It's up on you. Or you can solve as here. See, here you have dy and dx many times. Okay, it's like 1 2 3 1 2 3. Also, you can try for this, you can try to reduce this expression into this 5th case, but I will advise you to go for number 4 or number 3 case. Okay, case number 3 or number 4. So it's up on you. So now here you have a bunch of exercise. Suppose you have this one here, you know that this equation, this is a differential equation, this differentiation and this differentiation will not be the same, so it's not exact. So by looking here, I can see that this is what, which kind of function or which kind of differential equation or which kind of case is this. Okay, this is homogeneous, because here degree is 1 0, here degree is 1 1 1. So this is homogeneous, so you can solve by applying this non-exact homogeneous differential equation. So okay guys, just try by yourself and solve this one. Next video maybe we are going to solve some exercise, and yeah, and start now a linear differential equation like Leibniz equation. Okay, so this is what we are going to start, Leibniz equations. Okay, this is what we are going to start. Okay, this will be the layout. Okay, Leibniz equations like this. Okay, equation in these forms. This is what we are going to see in the next video. So hope you could enjoy this. Thank you. See you when I see you. Okay, invite your friends, call everyone, so subscribe, put your like, and yeah, life will be fine for everyone.